In this session, we are going to solve a few questions based on section formula. Let us take the first problem. Point P divides the line segment joining A of -1, 3 and B of 9, 8. So these are the 2 points, A of -1, 3 and B of 9, 8, such that AP is to BP is K is to 1. So if I mark the point P somewhere here, I know that AP is to BP is given as K is to 1. So this is the ratio given to me. If P lies on the line x minus y plus 2 equals 0. So let's consider that there is a line which passes through P and the equation of this line is given as x minus y plus 2 equals 0. We have to find the value of K. So if I think about this particular question, I know that AP is to BP is given as K is to 1. So what I'm thinking about is, can I find the coordinates of the point P? Of course, it will be in terms of K because the value of K is not known. So first thing that I should do here is find the coordinates of P. Find the coordinates of P in terms of K. In terms of K. Now once I do that, I know that the point P lies on the line. So as the point P lies on this particular line, I can say that the point P should satisfy the equation of the given line. That means in this equation, in x minus y plus 2 equals 0, whatever are the coordinates of P, I should substitute those coordinates of P and that will help me find the value of K. So this is what I think should be the right way to do it. So let us first go step by step. Let us first find the coordinates of P. So using section formula, I can find the coordinates of P. So P's coordinates would be K into 9, that's 9K, plus 1 into -1, that's -1, divided by K plus 1, comma, to find the Y coordinate, K multiplied by the Y coordinate of P, that is 8K, plus 1 multiplied by 3, that is plus 3, divided by K plus 1. These are the coordinates of P. Now as P lies on the line, x minus y plus 2 equals 0, I can substitute x by 9k minus 1 by k plus 1. So this would be 9k minus 1 by k plus 1 minus the value of y. So y is 8k plus 3 upon k plus 1 plus 2 is equal to 0. So basically what I've done is the x coordinate of P and the y coordinate of P, they should satisfy the equation x minus y plus 2 equals 0 because that particular line passes through this particular point. And hence I have substituted or I have replaced x with the x coordinate of P. I have replaced the y coordinate with the y coordinate of P. And now I am going to find the value of K. So the LCM of all these three terms is going to be K plus 1. The numerator is 9K minus 1 minus of 8K plus 3 plus 2 times K plus 1. So 2 times K plus 1 is equal to 0. I can cross multiply 0 and k plus 1. So k plus 1 into 0 becomes 0. So this equation becomes 9k minus 1 minus 8k minus 3 plus 2k plus 2 equals 0. Now 9k minus 8k is k and k plus 2k is 3k. Minus 1 minus 3 is minus 4. Minus 4 plus 2 is minus 2 equals 0. Solving this, I get the value of k as 2 by 3. So this is the value of k. So quickly to summarize this particular problem, we first found the coordinates of p in terms of k, of course, because the ratio was k is to 1. And then we substituted the value of x and y coordinates of p in the given equation because the line passed through this particular point. Therefore, the coordinates of p have to satisfy this equation, and that is why I replaced x and y with the x coordinates and y coordinates of p. So this is how I went about this particular problem. So pausing for a minute before taking up the next one. Moving on to the next question. Let's consider the following question. Calculate the ratio in which the line segment joining A of 6, 5. So A of 6, 5 and B of 4, minus 3, B of 4, minus 3 is replaced by the line or is divided by the line. Sorry, replaced is the wrong word. Is divided by the line y equals 2. So there is a line which is y equals 2. This is the line y equals 2. Now this particular line y equals 2 is intersecting the line segment AB at the point P. I want to find in what ratio is this line y equals 2 dividing the join of points A and B. So I can say let the line y equals 2, divide the line segment AB, in the ratio m is to n. That means this is m is to n, and now I can use section formula. So using section formula, I can find the coordinates of P. So coordinates of P are P. So if I find the coordinates of P, it is m into 4. So it is 4m plus n into 6, that's plus 6n divided by m plus n. And the y coordinate would be, so I take m and multiply it with the y coordinate of P, that's minus 3m. I take n and I multiply it with the y coordinate of A plus 5n divided by m plus n. Now it is given that the line is y equals 2. That means the y coordinate of P has to be 2, because every point on the line y equals 2 will have their y coordinate equal to 2. That is why the equation of this line is y equals 2. That means the y coordinate of P, that is minus 3m plus 5n upon m plus n. This is the y coordinate of P, and because P lies on the line, so as P lies on the line y equals 2, it implies that the y coordinate of P should be equal to 2. because that is the meaning of the line of the equation y equals 2. So that means minus 3m plus 5n divided by m plus n should be equal to 2. Cross multiplying, minus 3m plus 5n is 2 times m plus n, and therefore minus 3m plus 5n is 2m plus 2n. Therefore, I can say that 5n minus 2n is equal to 3m plus 2n, and therefore 3n is equal to 5m, which means m upon n is equal to 3 upon 5. And therefore, I can say that m is to n is equal to 3 is to 5. Therefore, the line y equals to, the line y equals to divides the join of AB, in the ratio 3 is to 5. This is my final answer. So the key idea here was, because the line was y equals 2, we know that the y coordinate of the point is going to be equal to 2. So when I say that the equation of a line is y equals 2, it means every point that lies on that particular line should satisfy the condition y equals 2. That is why it is the equation of that given line. So using section formula, again I found the y coordinate of P and I equated the y coordinate of P to 2, and from that I was able to find m is to n. So this is how I approached this particular problem. Moving on to the next question. If the line segment joining points P of minus 4, 5. So let us approximately plot the point. So it is P of minus 4, 5 is going to lie in the second quadrant. So this is P of minus 4, 5, and Q of 3, 2. So Q of 3, 2 lies over here in the first quadrant. Intersect the y-axis at R. So these two points are joined and it is intersecting the y-axis at the point R. So this is the y-axis, and PM and QN are the perpendiculars from P and Q to the x-axis. So PM is the perpendicular from P to the x-axis. QN is the perpendicular to the x-axis. So these are the two perpendiculars. So this is M and this is N. These are the perpendiculars drawn to the x-axis. First we have to find the ratio PR is to RQ. That's the first question. Second, we have to find the coordinates of R, and then we have to find the area of this particular quadrilateral PM and Q. So we know that R lies on the y-axis. So because R lies on the y-axis, I can say that coordinate of R is therefore going to be 0, y. Now why is it 0, y? Because the point lies on the y-axis, and hence I can say that the x coordinate is 0 and the y coordinate is some value which we do not know right now. But I definitely know that the x coordinate is 0. So now I will say let R divide, or let PR is to RQ be M is to N. So let this be M is to N. And now using section formula, I can frame certain equations. So using section formula, I can say that the x coordinate of r, so that's 0, is equal to m multiplied by x coordinate of q, that is 3m, plus minus 4 multiplied by n, that's minus 4n, divided by m plus n. Similarly, the y coordinate of r, that's y, is equal to m multiplied by the y coordinate, that's 2m, and 5 multiplied by n, so plus 5n, divided by m plus n. This is using the section form. Now, if I want to find the value of m is to n, I certainly know that using the second equation is of no use, because the value of y itself is unknown. And therefore, I would use the first equation. So 0 multiplied by m plus n is equal to 3m minus 4n, which means 0 is equal to 3m minus 4n, which means 3m is equal to 4n, and therefore I can say that m upon n is equal to 4 upon 3. Therefore, the ratio is 4:3. Now I need to find the coordinates of the point R. So to find the y coordinate of R, so y coordinate of R is already found out, right? This is the y coordinate of y. So in place of m, I simply can substitute 4. So y coordinate of R is going to be 2 times 4 plus 5 times 3 divided by 4 plus 3. And this is going to be 8 plus 15 divided by 7, which is equal to 23 by 7. Therefore, I can say that the coordinate of R is therefore equal to 0, 23 upon 7. This is the coordinate of the point R. Now they are asking me to find the area of this quadrilateral. So this is basically a trapezium, if you think about it. The area of a trapezium is given by half times the height multiplied by sum of the parallel sides. If you think about the parallel sides, PM and QN are the parallel sides. This height is 5 and this length is 2, right? And the height is the distance between the parallel sides. So the distance between these two parallel sides is, this is 3 and this is 4. So the distance is 7 units. Therefore, this is going to be half of 7 multiplied by the sum of parallel sides is 5 plus 2. And this is therefore going to be 24.5 square units. Right? This is going to be the area of this particular trapezium. So again, to summarize, I used the section formula. The important idea that I used here was, because R lies on the y-axis, its x coordinate is 0, right? And then I found m is to n. And once I found m is to n, I was able to find the y coordinate of R also. And then finding the area of this quadrilateral was finding the area of the trapezium, for which I used the formula of trapezium. It was half h times a plus b, where a and b are the parallel sides. So using my understanding of abscissa and ordinate, I was able to find the length of the two parallel sides as well as the distance between them. This is how I solved this particular problem. Moving to the next question. If the points are collinear, find the value of P. So these are the 3 points. So let us draw a diagram. These are the 3 points which are collinear. So A of 4, minus 5, B of 1, 1, and C of minus 2, P. These 3 points are collinear. We have to find the value of P. So I am going to use section formula to do this. Of course, to show that the points are collinear, there are many ways of doing it. But because we are discussing problems related to section formula right now, that is why I am going to solve this using section formula. So first of all, let me find the ratio m:n in which point B divides the join of AC. So I will say since A, B, C are collinear, and I can also represent it in this manner, A dash B dash C. So now I can say that let B divide the join of AC in the ratio m:n. So therefore the x coordinate of B 1 is going to be, so now I am using section formula. So x coordinate of B is 1 is equal to m into minus 2, that's minus 2m, plus n into 4, that's plus 4n, divided by m plus n. And similarly the y coordinate of B, which is also 1, is equal to m multiplied by P. So m multiplied by P, because m gets multiplied with the y coordinate of C, plus n gets multiplied with the y coordinate of A, that is minus 5n divided by m plus n. So now using the first equation, I can cross multiply. So using the first equation, I can find m:n. So m plus n is equal to minus 2m plus 4n, which means m plus 2m is equal to 4n minus n. Therefore 3m is equal to 3n, which means m upon n is 3 upon 3, which is equal to 1 upon 1. And this implies m:n is 1:1. So this implies m:n is 1:1. And now I can substitute m as 1 and n also as 1. So 1 is therefore equal to m is 1. So p minus 5 upon 1 plus 1. So what I've done is I substitute m and n as 1, because that is what we got. The ratio is 1:1 in the second equation. So therefore 1 is equal to p minus 5 by 2, which means p minus 5 is equal to 2, and therefore p is equal to 7. Now I was able to apply the section formula only because these points were collinear. Okay, I wouldn't be able to apply section formula if these points were not collinear. So because the points were collinear, one important condition for using section formula is when all the points have to be collinear. And because the points were collinear, I was able to use section formula, and this is how I went about this particular problem. So pausing for a minute before moving on to the next one. Moving on to the next question. Three consecutive vertices of a parallelogram ABCD are given. We have to find the fourth vertex. So let us consider that this is the parallelogram and three of its vertices are given to us. So A of 10, minus 6, then B of 2, minus 6. Please note that because the parallelogram is ABCD, I have to write the vertices in order. So I shouldn't be writing C here, that would be a mistake. C should be written here because that would mean that A, B, C and D are continuous. So C is minus 4, minus 2. And then of course the fourth vertex here is D. And we have to find the coordinates of this vertex. So I would say let the coordinates of D be. Let the coordinates of the point D be x, y. So now I know that there is a very important property that a parallelogram has, and it is the diagonals to bisect each other. So I can say that the midpoint of AC and the midpoint of BD, they exactly overlap. So O is the midpoint of AC as well as O is the midpoint of BD as well. So I can say that O, before that diagonals of a parallelogram bisect each other, which means that O is the midpoint of AC. O is the midpoint of AC as well as O is the midpoint of BD, right? Now if I were to find O, so if I take O is the midpoint of AC, and therefore using midpoint formula, the coordinates of O are 10 plus of minus 4 divided by 2, minus 6 plus of minus 2 divided by 2, and that is going to be 10 minus 4 is 6 by 2 is 3, minus 8 by 2 is minus 4. So the coordinate of O is minus 3 minus 4. Similarly, using midpoint formula, I can now apply midpoint formula for BD as well, midpoint formula for diagonal BD. So I can say that the coordinate of O is going to be x plus 2 divided by 2, y minus 6 divided by 2. And because it refers to the same point, right? O is the same point in both cases. So the ordered pair should be equal in both cases. That means x plus 2 by 2 is the x coordinate of O. That should be equal to 3. And similarly, y minus 6 upon 2, that's the y coordinate of O, should be equal to minus 4, right? So now I can solve these two equations and therefore I get value of x is 4 and the value of y is minus 2. Therefore, the coordinate of D is therefore equal to 4, minus 2. This is how I go about finding the fourth vertex of the given parallelogram. Moving on to the next question. In this question, we have to determine the ratio in which the line 3x plus y minus 9 equals 0 divides the line segment joining A and B. So there is a line segment AB. A's coordinates are 1, 3. B's coordinates are 2, 7. And there is a line which is dividing this particular line into two parts. The equation of this given line is 3x plus y minus 9 equals 0. And let the point of intersection be P. So now we have to find in what ratio is P dividing the line segment AB, right? This is the question. So I can say let P divide the line segment AB in the ratio m:n. So let P divide the line segment AB in the ratio m:n. And now I can find the coordinates of P, right? Using section formula, I can do that. So coordinate of P using section formula is going to be so m multiplied by the x coordinate of B, that's 2m, plus n multiplied by the x coordinate of A, that is n, divided by m plus n, comma m multiplied by the y coordinates, that is 7m plus 3n upon m plus n. This is the coordinate of P using the section formula. However, the point P lies on this particular line. So I can say that P lies on the line 3x plus y minus 9 equal to 0. And therefore, the coordinates of P should satisfy the equation, right? Should satisfy the equation. That means I can replace, so I have 3x plus y minus 9 equal to 0. What I can do is, because P lies on this particular line, in place of x, I can now substitute the x coordinate of P, that's 2m plus n upon m plus n. And in place of y, I can substitute the y coordinate of P, that's going to be 7m. That's going to be 7m plus 3n upon m plus n. And therefore, I can now simplify this equation for m:n. So now we can simplify this. We get 6m plus 3n divided by m plus n plus 7m plus 3n divided by m plus n minus 9 equals 0. The LCM is m plus n, so I can write this as m plus n. This is 6m plus 3n plus 7m plus 3n minus 9 times m plus n is equal to 0. Cross multiplying m plus n with 0, you get 6m plus 3n plus 7m plus 3n minus 9m minus 9n is equal to 0. So 6m plus 7m is 13m, 13m minus 9m is 4m, 3n plus 3n is 6n, 6n minus 9n is minus 3n is equal to 0, which means 4m is equal to 3n, and this implies m upon n is 3 upon 4. So therefore, the given line divides the line segment AB in the ratio 3:4. So what we did in this particular question was we started off with m:n as the unknown ratio. Using section formula, we found the coordinate of P, and then because P lies on this particular line, it should satisfy the equation. So we just substituted the x coordinate and y coordinate of P in place of x and y in this particular equation, and that is how we found the value of m:n. So pausing for a minute while you take a look at the detailed solution. Moving on to the next question. So let's take up the following question. Find the reflection of the point P of minus 3, 7. So this is P of minus 3, 7 in the point M of 5, minus 1. So I have to find the reflection of this particular point, right? I have to find the reflection of this point in point M. Assume that M is where a mirror is placed. So the reflection of the point P is going to be formed somewhere over here. And because this is reflection, I know that the distance between, so this is the point, this is its image. And here M is the mirror, right? I know that the distance between the object, P is the object. So the distance between the object and the mirror is going to be equal to the distance between the mirror and the image. Which in turn means that, this basically means that, so let the reflection of point P in point M be Q, and because this is reflection, it means that PM is equal to QM, and that implies M is the midpoint. M is the midpoint of PQ. M is the midpoint of PQ. So I need to find the coordinates of Q. So let Q be Q of x, y, right? So the coordinate of Q is Q of x, y. And now I can say that using midpoint formula, I can say that minus 3 plus x the whole divided by 2. So I have taken the x coordinates of P. The average of these two should be equal to 5 because that's the x coordinate of M. And similarly, minus 1, that's the y coordinate of M. Y coordinate of M should be the average of the y coordinates of P and Q. That is 7 plus y divided by 2. So now if you solve this, you get x equals 13. So minus 3 plus 13 is 10. And 10 divided by 2 becomes 5. And similarly over here, if you solve this, you will get y equals negative 9. Therefore, the point Q will have coordinates 13, minus 9. So reflection in the point basically meant that I had to use the midpoint formula to find the coordinates of the image. Moving on to the next question. Let's solve the following question. Point P divides the line segment joining A of 2, 1 and B of 5, minus 8 such that AB is equal to 3 times AP. So let's understand what this basically means. This means that the length of AB, so if I consider AP as length x, if AP is x, then I know that AB is 3 times x. So P is a point somewhere on this particular line segment. So this is P. If AP is X, if the length of AP is X, then the length of AB, that is this whole length is 3x, which implies that the length BP is going to be 3x minus x, which is basically going to be 2x. So this particular length is therefore equal to 2x, and therefore I can say that AP is to PB, because this is important for us to apply section formula, isn't it? To apply section formula, I should know AP is to PB, and that is x is to 2x, which means that is equal to 1 is to 2. This in short means that P divides AB in the ratio 1 is to 2. And if it divides AB in the ratio 1 is to 2, now I should be able to find the coordinate of P using section formula. So I will say using section formula, the coordinate of P is going to be, so let me write the ratio here. The ratio is, okay, let me leave it as it is. Let me write the ratio below the line. So the ratio is therefore 1 is to 2, and therefore P is going to be 1 multiplied by 5 plus 1 multiplied by 5 plus 2 multiplied by 2. So plus 2 multiplied by 2 divided by 1 plus 2, comma, the y coordinate of P is 1 multiplied by minus 8, 1 multiplied by minus 8 plus 2 multiplied by 1 plus 2 multiplied by 1 upon 1 plus 2. And this is going to be 5 plus 4 is 9 by 3, that's 3, comma, so the coordinate of P is going to be 3, comma, minus 8 plus 2 is minus 6 by 3 is minus 2. Therefore, the coordinate of P is going to be 3, comma, minus 2. Let me repeat this one more time, just so that you understand it very well. See, it was given that AB is 3 times AP. So if I assume that AP is X, that means the length of AB is equal to 3x, because AB is 3 times AP. And therefore the length of BP can be found out as 3x minus x, which is 2x. And therefore AP is to PB is going to be x is to 2x, xx cancels, that's going to be 1 is to 2. So P divides this in the ratio 1 is to 2. And because the ratio is now known, I can use section formula to find the coordinate of P. Now I have found the coordinate of P. It is also given that P lies on the line. So there is a line which passes through P. So P lies on the line 2x minus y plus k equals 0. Now as P lies on this line, 2x minus y plus k equals 0, the coordinate of P should satisfy the equation, which means 2 times the x coordinate of P. So I am replacing x with the x coordinate of P, because P should satisfy this equation. So 2 times 3 minus of y is minus 2 plus k equals 0. So 6 plus 2 is 8 plus k is 0, which means k equals minus 8. This is how I find the value of k. So let me pause for a minute. Some concepts that were used here, I used the concept of common ratio to find AP is to PB. I used section formula to find the coordinates of point P. And if a point lies on the line, it should satisfy its equation. That was another concept that was used in this particular problem. So pausing for a minute before taking up the next question. Moving on to the next question. Prove that these points are the vertices of a rhombus. So how can I find whether these are the vertices of a rhombus? Of course, I can use distance formula to find all the four distances. So I have been given a quadrilateral which is ABCD. Let me find all the distances. So A is 4, minus 1, B is 6, 0, C is 7, 2 and D is 5, 1. So now I am going to go ahead and use distance formula. So using distance formula, I am going to find the length AB. So AB is therefore going to be under root of 4 minus 6 the whole square plus minus 1 minus 0 the whole square. Similarly, BC is going to be under root of 6 minus 7 the whole square plus 0 minus 2 the whole square. CD is going to be under root of 5 minus 7 the whole square plus 1 minus 2 the whole square. And DA is going to be under root of 5 minus 4 the whole square plus 1 minus of minus 1 the whole square. So this is going to be under root of, this is minus 2 the whole square is 4 and negative 1 square is 1. This is going to be 6 minus 7 is minus 1 square is 1 and negative 2 square is 4. This is going to be under root of minus 2 square is 4 and minus 1 square is 1. And this is going to be 1 square is 1 and 2 square is 4. So you will find that each of these distances is equal to square root of 5 units, right? So all these distances are equal, which means that the four sides of this particular quadrilateral are equal, and if the four sides are equal, we say that this particular figure is a rhombus. Now to find whether it is a square, there's a simple check. I can simply go ahead and find the diagonals. So diagonal AC, let's find the length of diagonal AC. That's going to be under root of 4 minus 7 the whole square plus negative 1 negative 2 the whole square. So when I'm finding the length of the diagonal AC, I'm taking the coordinates of A and C. And similarly, diagonal BD is going to be under root of 5 minus 6 the whole square plus 1 minus 0 the whole square. So this is going to be under root of negative 3 square is 9 plus negative 3 square is 9 and that's root 18 units. Whereas this is negative 1 square is 1 and positive square is also 1, so this is root 2 units. So because the diagonals are not equal, so as diagonal AC is not equal to BD, I can say that the given figure is a rhombus because all sides are equal, is a rhombus but not a square, right? Because the diagonals are not equal to each other. So I hope you understood this particular question and all the previous questions that were solved. This was the last question of this session. I will pause for a minute and end today's session here. ending today's session here.